okay, I got it covered. I have all.
All right, we are doing Chapter 2 review, and we are not going through the review pages in the book. Those are on 91, so if you guys would like to do that yourself to study, I highly suggest it. They go by section. But today we are going to go through Chapter Test B as a review because Test A is what they are going to do in class. Now, if you guys can see, between my two Test A's, what I've done is I've made my own notes, and I do want to go through that as well, okay?
Wait, we're allowed to use our note cards, right?
You are allowed to use your note cards, and your note cards should look something like this, right?
Yeah.
Okay.
Oh, didn't you say we were going to work on the note cards today?
If we find time, we can, yeah. Okay. So, yeah, those are good. Let's talk about this real quick, and then we'll go through Test B. Congruent means the same all around. Congruent means the same shape, the same size. So when we go over these pages, I would like you guys to write these down just for review, okay? So at the top of your notebook paper, write Chapter 2 review, just like how I've done. And then I want you to write congruent means the same. Same shape, same size, same everything, okay?
Can we use these ones?
Sure. Translation rules. We learned this in the first section, okay? Translation just means slide. Here are the rules. If you see the word up or down, it means you're dealing with the y coordinate, okay? If you see the words left or right, it means you're dealing with the x coordinate. We also learned that up means you're adding, down means you're subtracting, the word right means you're adding, and left means you're subtracting, okay? We put those in our special notes, and you guys put those on your note cards before, right? So this shouldn't be new information to you.
Can you post a picture of that on Classroom?
Of these notes?
Mm-hmm.
Well, I'm videoing it right now, so you can watch the video and pause it. Yeah. I also put a quick little example. So if I had this coordinate, this point, and I said, I want you to go up 4 units and left 3 units, I showed you up means you're dealing with the y coordinate, right? It also means you are going to be adding. So I said we're going to add 4 to the y coordinate, okay? Left means I'm dealing with the x coordinate, and left also means subtract. So I went to my x coordinate and I subtracted, okay? That's how we use those rules. Up means y, left means x, up means add, left means subtract. Okay? Any questions on translations? Nope. Okay. Let's talk about reflections. Another word for reflection means to flip it. Okay? If you are reflecting across the x-axis, the y coordinate changes its sign. If you're reflecting across the y-axis, the good. And I gave you 2 examples down here. If I had this point and I said reflected across the y-axis, if we're reflecting across the y-axis, the x coordinate changes sign. So which one's the x, the 7 or the -6? The 7. So I'm just going to change it to its opposite sign, which is -7, -6. Okay? Easy? Reflections are super easy. If I had this coordinate, 2, 6, and I said reflected across the x-axis, the y coordinate changes to its opposite sign. So it'd be 2, -6. How you guys feel about those 2 things, translations and reflections? Feel okay?
Mm-hmm.
Okay? After that, we talked about rotations. Another word for rotation is a turn or a spin, right? Okay. We had 2 different sets of rules. We had counterclockwise rules and clockwise rules. The only one that stayed the same was 180 degrees for both, right? What I mean by stays the same is that the rules are the same. The x and the y just turn to their opposite sign. Yes?
Yeah.
Okay. And we wrote those down. And if you don't have them written down, you can watch this video tonight, pause it, and then write them down, right? Those rules only work if If we're not rotating about the origin, we can't use these rules, okay? Over here, you can see this little drawing I had going on. Let me erase this part of it. If I had a shape in the first quadrant and I said I rotated it 180 degrees, do I have to specify clockwise or counterclockwise?
No, 180.
It's going to land in the same spot no matter what, right? And it will always land in its opposite diagonal quadrant, right? So it would land somewhere over here. Yes?
Yeah.
Okay, so what if my shape was over here?
So the one
Yeah, it'd land over there, right? Okay, that's 180 degrees. 90 degrees, you can kind of think of it being as like its own quadrant, kind of moves over a quadrant, right? So if I had a shape right here, 90 degrees counterclockwise would land over here. 90 degrees clockwise would land over here, right? Okay, how do you guys feel about rotations?
pretty decent.
Those are my least favorite ones out of everything, just because they're hard for me to visualize. Because sometimes, if it's not about the origin, it's hard to picture where it would land, right?
That's the only one that is the ones that don't rotate around the origin.
Yeah, like if they rotate about a point,
Yeah, I like that.
right, we'd have to just like make the degrees. So, for example, let me find one. See if there is one. This isn't one, but let me just give you this as an example. What if I said rotate this triangle 90 degrees clockwise about the origin? Oh, no, sorry, not about the origin. How about point A? Want to do about point A?
Yeah.
Okay. A is the pivot, right? The center of rotation.
Just count 3 down.
Yeah, so if it rotates 90 degrees, here's what I want you to do. Can you make me a 90-degree angle from point A to point B? So there's one line, right?
Mm-hmm.
Now, a 90-degree angle would be like out here, right? Is that 90?
Yeah.
It wouldn't be here. That's 180.
Oh, yeah.
It wouldn't be here. That is 90, but clockwise, that's 270, right? So clockwise from here would just be straight out to here, right? Okay, so this is how you do it if it's not about the origin. So that was where B prime would land. A prime is going to stay where it's at. Now, if that's where B prime is, C prime is going to go straight down from A.
Yeah.
1, 2, 3.
What I meant is you count down from A to where
That makes sense.
3
Yeah.
to C.
Yes.
That's what I meant.
So when you're rotating and it's not about the origin, it's about a certain point, here's my trick. Take the pivot and choose a straight off line from the pivot. So could I have gone to C as well?
Yeah.
Yeah, okay, so let's say we go from A to C, right? Now, if I said let's move C 90 degrees clockwise, I know it would land here, oops, right here, because from this to this is 90 degrees, right?
Yeah.
What if I said let's move it 270 degrees clockwise? Well, then it would have to go all the way around. 270 would be something like this, right? From here to here. Because one of those, that's 90. Another one would be another 90. It would be 180. Another one would be 270, right? It's a little more complex, and that's why rotations are not my favorite, is because it's harder for kids and me, adults, to visualize it, right? But I don't know if you'll have any that aren't about the origin. Like, for example, this is on test B, and it says rotate it 180 degrees about the origin. Can you use your rules?
Yeah.
Yeah, super easy. And it looks like that's the only one on there that asks you to do that. Here's the actual test. This one says rotate the triangle 180 degrees about the origin. So that's nice. Can you use your rules on that?
Yeah.
Yep. Okay, we'll keep going. Let's talk about dilation. That's the newest one that we've done. It either means to grow or to shrink, right? I had some 8th graders yesterday, not in this class, but the other classes, just say that dilation means to get bigger.
Oh, no, I can.
It can also shrink, right? So dilation just means that it grows or shrinks. If you multiply by a whole number, you will grow. If you multiply by a fraction, you will shrink. So if you look down here, I gave you an example. The scale factor is always labeled with a K, right?
Yeah.
So that's scale factor. If I said dilate with a scale factor of 2/3, I already know my shape is going to shrink. All you do is take 2/3 and times it by both of these, okay? Now, the scale factor that we had been given lately had always been a fraction with a 1 in the numerator. And so that's why I said just take this part and divide everything with it, right? Well, is that going to be the case always? No, sometimes it is things like 2/3, right? All you do is take the first number, which is 3, times it by 2/3. How do I times a whole number by a fraction? There you go, yep. So then it'd be 3 times 2 is 6. 3 times 1 is 3. 2. Yeah. Okay? So scale factor is easy. All you do is you just multiply what the scale factor is to those numbers. Make sense?
Yeah.
Okay, how you guys feeling about dilations?
Good.
Good? I think you guys are good. This is your note card.
4, yeah.
Okay? Okay. Sweet. Okay. If the shapes are similar, they are the same size, but, they are the same shape, but different sizes. Yeah, good. You can prove that they are similar by setting up a proportion and cross multiplying. Okay, that's the entire chapter right there. Shall we do test B now?
I have a question.
Yes.
What's our homework for tomorrow? Because
We have a test.
oh yeah.
Okay. Test B. The trapezoids ABCD and EFGH are congruent. That's nice to know. Which side of EFGH is congruent to side AD? Where's his corresponding side? GF. Oh, wait, is it GF?
No, it's H-E.
HE. So I'm going to say HE.
Because it was flipped.
Yep, good. So I'm going to go and highlight that one so you guys remember we just did him. Boop. Okay. The perimeter of ABCD is 30 centimeters. What would be the value of X? Ooh.
Multiplied by the perimeter.
Well, they're telling me the perimeter of this shape is what? 30?
Yeah.
What is perimeter?
The distance around
So it's this side plus this side plus this side plus this side will all equal
30.
30. We can do that. Isn't that something we did last chapter?
Yeah, 30 plus X plus 5 plus X. So you would add the X's together.
So you'd say X plus, what'd you say? X plus 5 plus X plus 13 equals 30?
Yeah, we did that last. Yeah, you add all
Yes, we did. Okay, so how many X's do you see?
3, so it'd be 3 X's plus 3 X.
Now do the numbers. 5 and 13 is 18? You're just adding them. What's 13 plus 5? Yeah. Don't go for your calculators. Watch this, guys. Put the 5 in your head. Ready? 5. Now do the touch points for the 3. 5, 6, 7, 8. So I know my ones column is going to be an 8, and then just take the 1 and boop, it's 18.
10 plus 5 is 15.
Yeah. Plus 3 more would be 18.
I have
So
one.
now you do divide by 3.
Okay, so hold on. Hold on. Hold on.
No, you subtract by 18.
Why do I not divide by 3 first?
Not get rid of the jump.
Get rid of that extra stuff around it, right?
Yeah.
Did I tell you guys what my mom said about the reverse order of operations?
Oh, yeah.
So, a good explanation of why do we get rid of this first and not this first is because when you're trying to get x by itself, you do the reverse order of operations. Normally in order of operations, we like to multiply and divide first, right?
Yeah.
But the reverse of that would be to add and subtract first.
I have
Okay.
an answer.
Okay, so hold on. What do we do? We take away 18
Yep.
from both sides.
Yep. Be 12.
Okay, so 3x equals 12.
Divide by 3 is 4.
Very good. X equals 4. So my question said, let me erase my box so that I can actually see what it said. My question said the perimeter of ABCD is 30. What would the value of x be?
4.
X equals 4.
Now, if you check it, you can't get an answer.
Yeah. Plug it back in, right? And everything together should equal 30. What is the length of EF? So hold on. You just told me x was 4, right? So this is 4. This is 4. This is 4 plus 5, which is 9. What is the length then of EF?
9. 4. 4. Wait, 9. Wouldn't you just do C?
Yeah, who's his corresponding side?
4. C and D.
CD? Yeah, so CD is 4, so then EF would be
4.
4.
So many 4s. What the heck?
What is the length of GF?
13.
Nope.
9.
Remember, you got to flip it. Whoop.
9.
9. Okay. 5. Tell whether the shaded figure is a translation, a reflection, a rotation, or a dilation. So number 5,
Reflection.
do you guys see the line of reflection that would be right there?
Yeah.
How about number 6?
Rotation.
Good, I can tell that that rotated either 90 degrees that way or 270 degrees that way.
I didn't even see the bottom figure.
You didn't see this one? You just thought, oh, it's just a it's just a thing. How about 7?
Dilation.
Very good. How about 8?
Translation.
Translation. Remember, translation's just a slide. Okay? Number 9. The vertices of a triangle are this. Hold on, let me get my highlighter a little bigger. X, Y, and Z. Dilate that triangle with respect to the origin with a scale factor of,
1/3.
then reflect it across the x-axis. This is very similar to you guys' quiz.
Divide everything by 3.
Okay, so,
Not my head. Whiteboard. Oh, yeah.
sure. You guys want to try this one on your whiteboard real quick?
Yes.
So you'll have
That's a good idea.
x prime, y prime, and then z prime. Do you guys remember though that what if they didn't say that the scale factor was 1/3? What if they were mean and said it was 2/3? You don't then divide by 3, right?
Yeah.
We would multiply by 2/3.
Yeah.
The reason why we're dividing by 3 is because multiplying by 1/3 is the same thing as dividing everything just by 3, okay? Just know that that's why we're doing it this way. Okay, so you guys are working on x prime, y prime, and z prime. So the first one I'm getting, check your work, -2, -3.
Yes.
Yeah.
Watching your negatives?
Mm-hmm.
Okay. The next one would be -1, -3.
Yeah.
And then z prime would be -1, -1.
Yep.
Okay, we're not done yet.
The y coordinate.
Then reflect it across the x-axis. So now we're going to have double prime, right? We're going to have x double prime, y double prime, and z double prime. So if we're reflecting across the x-axis, the y coordinate changes. So it's going to be, good, -2, +3. -1, +3.
-1.
Good job, guys.
That was actually not bad.
Easy.
I can do it in my head, but like, it's like I need to have it written down.
Yeah,
I get lost.
me too. I could do it, I could say it out loud, but then I wouldn't remember what I had just said because my brain doesn't work that way. Okay, number 10. Rotate the triangle 180 degrees about the origin. Did they specify counterclockwise or clockwise?
Because 180 is the same.
Perfect. So I know, and I hope you guys know, that it's going to land over here somewhere
Mm-hmm.
because it's the opposite quadrant.
Yeah.
Okay. After we rotate it, then I want you to translate it 3 units to the right and 2 units up. What are the coordinates of the final image? So, I know you guys don't have a coordinate grid right here, right? But, looking at your special rules, what are the rules for a rotation of 180 degrees?
They become both negative.
To their opposite sign?
Yeah.
They don't switch places, do they?
No.
So, do you think it would be smart to first list the coordinates for A, B, C?
Yep.
So I know what's actually rotating? A is,
1,
1, 1,
B is,
1, 2,
C is.
4, 1.
Now you just told me after a rotation of 180 degrees,
-1,
they just turn to their opposite signs,
Yeah.
both the X and the Y. So this would be -1, -1, -1, -2, -4, -1.
Yep.
Go plot that now. Okay, so I'll go put it on here and you guys make sure I'm doing it right. -1, -1,
Mm-hmm.
-1, -2, -4, -1. How's it look?
Good.
Good? Now, we're not done. Translate it 3 to the right, 2 up. So take each of these, ready? And move them 3 to the right, 1, 2, 3, up 2.
And we have to find those coordinates.
Oh, this is so
So this would be A prime prime.
weird. Yeah.
1, 2, 3, 1, 2. That'd be B prime prime. I'm going to erase some of my jumps because I don't want that to screw me up. Okay. And now C. 1, 2, 3, 1, 2. C prime prime. Boop. How's it look?
Good.
We did it. First we rotated it, then we translated it. The final question said, though, what are the coordinates of new C prime prime, A prime prime, B prime prime? So let's do it. A prime prime.
2, 1.
You said 2, 1 for A?
Mm-hmm.
I know. Mine's all crazy.
I can't
B,
2, 0, 2.
0, 2, 2, 0.
Oh.
Remember, the first one is the X. We went over 2 and then up and down none. How about C?
1, negative 1, 1.
Good. There you go. There's your answer. I think you guys are going to do such a good job on this test, honestly. Because if you can do that, if you can do number 9 and you can do number 10, you're going to ace this. Like, really. Okay?
Number 9 was easy.
Number 9 was fun, wasn't it?
Yeah.
I like those ones. Okay, this is the backside of test B. The polygons are similar. Find X.
Oh. You just do 15 over 20.
15 is to 20 as
And 6 is
to X. So how do I solve this now?
cross multiplication.
What's 20 times 6?
Oh, that would be 120.
120?
Yeah.
What's 15 times X?
15X.
How do I get X by itself?
I feel like we'd had this one on the problem before.
Those numbers look similar, don't they?
Yeah. Why?
What's 120 divided by 15?
24.
Is it 24?
Beautiful.
And that was 5. Oh yeah, that was 5. 8.
8. That's all you had to do. Just find X. Could we do the next one?
Yeah. Yeah.
Okay.
8 over 20 is 2 over x. This is so easy. for
It is
no
easy.
reason.
What is 14 times 20?
280.
What's 8 times X?
8x.
What's 280 divided by 8?
35. Yeah, Zoe.
So X is?
35, 35.
Woohoo! Do you guys have any questions on 11 or 12?
Nope.
Pretty easy?
Yeah.
How about the kids who aren't answering anything? You guys doing okay?
Mm-hmm.
Okay, I figured so. 13 and 14. Rectangles ABCD is similar to rectangle WXYZ. Tell whether the statement would be true or false. So the perimeter of ABCD and the perimeter of WXYZ is this.
Me and Zoe should let other kids start answering.
Is the ratio of their perimeters this? They're saying, imagine these two rectangles in your brains, right? They're saying side CD and side YZ. You would put that side on top of that side for the ratio of their perimeters, which you do that, right? But then they say you do what to it?
Square it, multiply by itself.
Is that how you find the perimeter?
Mm-hmm.
Or is that how you find the area?
That's like
Area.
on the area.
So what would you say for 13? Is that true or is that false?
False.
Oh.
How could I make it so it would be true?
Area.
You say it's to the area.
Oh, so you're saying I could change the word perimeter to area?
Yeah.
And then it would work, right? Or let's say you had to keep perimeter. Could you just get rid of this and just have CD over YZ?
Yeah.
Side over side? Yeah?
Yeah.
Okay. How about this? This says the area, the ratio of the areas would be CD over YZ.
Square. Yes. True.
Was that how you would find the ratio of their area?
Yeah.
You would take a side over their corresponding side and then square both of them?
Yep.
Yeah. That's all you would do, right? So, true. Weird way to ask that question, right?
Mm-hmm. Yeah.
It's almost easier if they would have just given you two shapes and said, find the ratio of their perimeter, find the ratio of their area. I guess they just wanted to see if you could understand it in different wording. All right, 15. Several transformations are used to create this quilt. Describe the transformation of design A to design B. I'm going to highlight it so we can kind of focus on one. Design A to design B.
Rotation.
Do you guys agree?
Yeah.
That that's just a rotation?
Yeah.
What kind of a rotation?
Oh, yeah, it's counterclockwise.
Could be a counterclockwise 90.
Yeah.
Could it also be a,
Clockwise 270.
yeah. I don't think they want you to specify that. I think they just wanted to see if you could say rotation. Okay? I was just curious what you guys thought. But yeah, so A would be a,
Translation.
hold on. You guys just told me it was a, Rotation.
Sorry, yeah.
okay. Now let's do the next one. Describe the transformation from E to G. That's F.
Oh, that's just a.
E
That's
to G. What is it?
Rotation. No. Wait, no. That's a.
Brindley, what do you think?
That's a
Trinity, what do you think?
translation.
No, because if it was a translation, it would look like that over here. The flower's on the opposite side.
It's a reflection.
Yeah, what she said.
Yes, it's a reflection. Can you guys imagine the line of reflection right here?
And rotation kept coming to my mind.
If that was the line of reflection, wouldn't the flower also be that far away from the line?
Yeah.
And then this point would be that far, this point would be that far, right? Good, so that is a...
Reflection.
I was gonna say rotation, but like I knew it
No.
was bad, and, like,
No, you guys are doing okay. I'm happy that you guys are figuring this out. Describe the transformation from design A to design H.
like that's a dilation.
Yay! Good job! That's a dilation.
By a fraction.
That's like a
Ooh,
trying to think.
Destiny. You know what Destiny just said?
No.
You would be translating, and the scale factor would probably be a fraction because she knows from A to H it shrunk. Yeah, that's awesome. I'm glad that you thought that way, Destiny. Okay, let's do the next one. It says from design A. So I'm going to highlight just A. Get rid of H. Which
She's not in this math class.
which design would be a reflection and a 90-degree clockwise rotation about the origin? So first of all, which one would be a reflection and then a rotation? Let's look at each of these.
Clockwise or counterclockwise?
It says clockwise 90. So I'm just going to look at B for a second, okay? You guys following me?
Yeah. Oh, and
If I could rotate B back so that it's orientated the same way as A, where the point's up here, right? It'd be like that. Yes?
yeah.
The flower would be up here, right? Are you guys seeing this?
Yeah.
Does that look like it was a reflection?
No, it wasn't. It was
They're the same, right?
it was
So B would just be a rotation, right? Okay, so B, sorry buddy, you are out of the possible running. H, that there's no way that could be a rotation and a reflection, right?
Yeah.
How about E? Like, for example, if I rotated A 90 degrees clockwise, 90 degrees clockwise about the origin, let's pretend this is the origin right here and this is our coordinate plane. Do we see this? A 90-degree rotation for A would look something over here, and the flower would be up here somewhere, right? I know it's really hard to visualize. Rotations are stinky. It'd be something like that.
F probably. Possible.
Does E look like that it could have rotated and then reflected?
It's just a reflection.
That's just a... I don't even know. I think
That's just a reflection.
He's just a
that's a reflection if E was up here, right?
Yeah.
If they were on the same level. Could I have reflected it over the X and then? I don't know. But yeah, John, you're right. That is a reflection. So E, hold on, I'm going to cross out our ones that are not in the run anymore. B, H, E, nope. How about F?
Yeah, possibly, yeah. Yeah. F could I.
So for example, if I moved A, if I rotated this 90 degrees clockwise, the flower would be facing the right direction, right, for F? And then for it to reflect, wouldn't it have to now be on the other side of the shape?
Yeah.
So
But
yeah.
They
wouldn't-
reflected and translated.
So is this one rotated and reflected?
Yep.
I can kind of see that one for F. Should we double check to make sure there's nothing else, just in case they accidentally like gave us two of them?
Yeah.
Okay, so I like F. Can we all agree that C is out of the running
Yeah.
because it's a dilation? Okay, how about D?
Kind of.
Well, it'd be counterclockwise.
Clockwise. No, it's clockwise.
It could be both though, right? But it would be 270.
Yeah.
So if I wanted it to rotate so that the flower was on top like this, oops. If I wanted it to rotate so the flower was totally upside down, that wouldn't be a 90-degree rotation, right? That would be 180 that way and 180 that way. So the flower being upside down is my biggest clue that it's 180 degrees. Okay? So you know what I'm going to say? He's out of the running. Because we need a 90-degree rotation, not 180. How about G?
G, no.
No, it's F.
G is a translation, right?
Yeah.
Okay, so my correct answer is F.
A and G look exactly the same.
Yeah,
to me.
that's what they are.
Which ones?
A and G.
Yep, A and G are the same. That's a translation. It just means it slid, right? It didn't like,
It didn't slide, it's in the same position.
well, right, but
Translation.
Oh,
they
it-
just-
translation means that it doesn't orientate any differently, right? It
Yeah.
just moves. Same image, just somewhere else, right? Okay. 16? Explain how you know if a dilation is an enlargement versus a reduction.
Oh, if it's multiplied by a whole number, it's growing. If it's multiplied by a fraction, it's shrinking.
There you go. What do we call those things that are being multiplied by things?
Square root.
Scale factor.
Scale factor. So if this one was on the test, I would want you to use the word scale factor. I'd say, if the scale factor is a whole number, my shape will be enlarging. If my scale factor is a fraction, it'll be a reduction. Okay? Use your big math words. Number 17. The ratio of the side length of square A to the side length of square B is 3 to 5. Hey, we had one similar to this, didn't we? On the homework or something? Here, let's do this one together. I know I've got squares. Can I assume that square A is the 3
Yeah.
and square 5 is the B, or the 5? Why do I assume that?
Because 5 is greater than 3.
And I can assume the bigger square has the bigger number, right? Okay. The perimeter, however, all the way around square B is 60. What could the area then of square A be? Okay, hold on. If each of these sides was 5, is 5 plus 5 plus 5 plus 5 60?
No, that's funny.
No. So here's what I'm thinking. I'm thinking they gave us the ratio 3 to 5 as a pre-reduced fraction. Can we unreduce it so that I can find a number that added up 4 different times would get me 60?
Yeah.
First of all, what number added up 4 different times would get you 60? 10 and 10 and 10 and 10 would be 40, so we're close. How about 15, 15, 15, 15? What's 15 and a 15?
30.
What's 15 and another 15?
30.
What's 30 and 30? 60. So, just by using mental math, I figured out each side has to be what?
15.
Okay, well, that means if I said that this was a reduced fraction and I'm unreducing it, and I said this had to be 15, what could the side lengths now of A be? Well, this is times by 3, right, to get there?
Yeah.
Could I also just times this by 3 to get there? Am I losing you? I think I've only got one listening. Yeah?
Yeah.
Okay. Do you see how I now found out that the actual side length of A is 9?
Oh,
Yeah.
They gave us the ratio is 3 to 5. I put 3 and 5 in their right places, but then I realized that had to have been a reduced ratio, right? Yes?
Yeah.
So I unreduced it by asking myself, well, what times 4, or, added to itself 4 different times, would get you 60? And it is 15. And if that's 15, how did this one change? So we just said, well, it looks like they reduced it by dividing it by 3, right? So then to redo that, or to do it the opposite, you'd multiply by 3. Kind of complex, right? Now the question is, what is the area of A? Well, I just found out the side is 9. Isn't all the sides 9 because it's a square? How do I find area?
You add up all the side lengths, so it
No.
That's perimeter.
Oh yeah.
Area equals length times width. What's 9 times 9?
81.
81. So what's the area of my square? 81 feet squared. There you go. Woof. That was a lot, wasn't it? We just did an entire test together. Yikes. Well, how do you guys feel?